Hello, trigonometry students. We are on lesson 50 here. This is on your textbook, page 342. We're working on trigonometric equations. I'm going to go ahead and take a look at star 1, and you're going to notice one detail here that is a little bit new, and that is giving us restrictions on theta. So these are just angle restrictions telling us that our final answer needs to come between 0 and 360 degrees. The first step I'm going to take then is I'm going to look at my trig circle, and I'm going to figure out where the cosine value of an angle is √3/2. Okay, I figure out where does this happen on a trig circle. And I find there are two places, in the first quadrant and in the fourth quadrant. So I find that theta 2 times has a cosine value of √3/2. It takes place at 30 degrees, and it takes place at 330 degrees. Okay, and both of those are within the restricted values. So it ends up being that both of those are solutions. All right, we're going to try a little bit harder question next. This time, I'm going to rewrite my problem down here. I have to do a little bit of algebra before I can start. So I'm going to subtract the √2 to the other side, and I get cosecant of theta equals negative √2. And then you should recall that cosecant is a reciprocal function for sine. So I'm going to rewrite this as a sine function, and then I'm going to flip the right side of the equation as well, and that would be -1/√2. And then by using the method of rationalizing your denominator, we know that that is the equivalent of saying sine theta equals -√2/2. Once again, I'm going to go back to my trig circle and identify when is the sine value equal to -√2/2. And I should find two different places where I have a -√2/2. Okay, that happens in theta equaling 225 degrees, and also theta will equal 315 degrees. Both of them are within our restricted area, so I calculate both of those. Okay, on question 3, let me rewrite that question. Once again, we're going to start off with some algebra. I'm going to add the 4 over. And then it looks like I need to divide both sides by 2√3. And before I rationalize that denominator, I'm working with secant of theta. So that is a reciprocal function. Let's go ahead and flip that and make it the proper function, which is cosine of theta. So I'll flip my fraction. And then in the final step here, I need to reduce that fraction. The 2 and the 4 can reduce. And that would be √3/2. So now I consult my trig circle, my unit circle, and figure out when is theta a value of √3/2 for cosine. And once again, I have two locations. This is a lot like star 1. It's going to happen at 30 degrees and 330 degrees. Okay, so two solutions there. We're going to go into the homework lesson. starting at question 8. And once again, we're in the textbook. This is actually on page 344. So question 8, the original question from the textbook, cosine of theta equals 1 over root 2. And it has restrictions from 0 to 360. I'm going to rationalize my root 2. I see cosine theta is in its regular form. So I would multiply root 2, top and bottom. Rewritten, I get cosine theta equals root 2 over 2. Consult the trig circle for that. And I find theta has 2 locations where cosine is root 2 over 2. That takes place at 45 degrees. And it takes place at 315 degrees. Both of those are solutions. And then I'm going to go over to question 9, also new for this lesson. The original problem reads -2 plus root 3 secant theta equals 0. Add the 2 over to the other side. And then let's divide that root 3 over to the other side. And check in with our function. It is secant. And let's remember that secant is a reciprocal function for cosine. So I'm going to rewrite this using cosine and flip my fraction. And then I check my trig circle to figure out where is cosine equivalent to root 3 over 2. And this happens at 30 degrees. And again at 330 degrees. Okay, and then I'm going to go ahead and do one more question with you. This is question 11. 11 has 2 parts. I want to try to squeeze in to make room for this one. Part A starts off with secant squared, 3 pi over 4, minus cosecant squared, pi over 4, minus cosine squared, 4 pi. And we are to evaluate. Okay, so there are a few different steps that we can use here. We can change all of our radian values into degrees. So I'm going to come back and look at just that radian value, 3 pi over 4, and convert that over to degrees. If you need to have a refresher on that, you can think of it as the pi equivalent to 180. So in this rewritten form, 3 pi over 4 is going to be 135 degrees. Pi over 4, think of it as 180 divided by 4. That's going to be 45 degrees. And 4 pi, that's 720 degrees. Okay, so let me go back now and put my other function notation in here. Now that I have it transferred to degrees, I'm going to address the squares on each of these items, and I'm also going to address the reciprocal functions. So secant is actually the reciprocal of cosine. I'm going to rewrite this part as 1 over cosine 135, and the whole thing is squared. Minus, and then cosecant, that's the reciprocal function of sine. So I'm going to rewrite this as 1 over sine 45 degrees. That entire thing is squared. Minus, and this one doesn't need to be flipped around, but we are going to change it. Instead of saying 720 degrees. Let me fix one thing there. 720 degrees is 2 sets of 360. It would mean the same thing as 0 degrees. And then we'll square it. Okay, so again, we look at our trig circle to figure out what some of these values are. The cosine of 135 degrees is going to be a negative root 2 over 2, but it's the reciprocal of that. So it actually ends up being negative root 2 squared. Sine of 45 degrees is 1 over root 2. Reciprocated is root 2 squared. Cosine of 0 is 1, and we square that. So that will bring us to 2 minus 1, which is a final value of negative 1. Okay, that was just for part A. So I'm going to scroll down a little bit and squeeze in part B. Part B, the original question, cotangent squared of negative 13 pi over 6 minus 3 tangent negative 7 pi over 3. Okay, so I am going to convert into degrees. This first one, negative 13 pi over 6. It's actually the same thing as negative 30 degrees. And the negative 7 pi over 3 is the same as negative 420 degrees. And then I'm also going to address the squared on this cotangent on my next run through. So I'm going to reciprocate the cotangent and I'm going to square it. Okay, so looking back now, negative 30 degrees, if you look on your trig circle, that's the same thing as saying 360 minus 30 degrees. So you're really at 330 degrees. If you figure out what your tangent is there, and then you reciprocate it, you're going to end up with root 3 squared minus 3 times negative root 3. And actually, I think this one's a negative as well. When I square it, the first one won't matter. It just becomes 3. And this would become plus 3 root 3. And that's my final answer for part B. All right, good luck, and let me know if you have any questions.